Hello dear friends, welcome to my channels. Today's discussions is Markov chain part 2. So friends, in this video we try to discuss classification of Markov chain, standard distributions in stationary distributions fusion. So friends, at first we have to learn classification of Markov chain. A Markov chain is said to be irreducible if every state communicate with every other state with every other state. Sorry, there is the double typing mistake, that if every state communicate with every other state. This portion I write. Reducible Markov chain. Markov chain is reducible if Ci does not equals to S. Ci does not equals to S means proper closed subset. Ci means proper, it is proper closed subset. Example xn such that n greater than equals to 1 is Markov chain state space 0, 1, 2, and p equals to 1 by 4, 5 by 8, 1 by 8, 1 by 4, 0, 3 by 4, 1 by 2, 3 by 8, and 1 by 8, and directed graph 0, 1, 2. So 0, 1 means 5 by 8, 0, you will see that it is 0, 1, 2 and 0, 1. So P00 means it is 1 by, and 0, 1 is 0, 0 to 1, 0 to 1 is 5 by 8, and 1 to 0, 1 to 0, this is 0, 1, 2, sorry, in way, 0, 0, 0, 0, so it is 1 by 4, and 0 to 2, 0 to 2, so it is 0 to 2, 0 to 2, it is 0 to 2, it is 1 by 2, and 2 to 2, it is 1 by 8, and 0 to 2 is equal to 1 by 8, and 2 to 1, it is 3 by 8, and 1 to 2, it is 3 by 4. So this is my directed graph. Now we want to solve. Ci equals to j belongs to S, I belongs to S, where I are communicated, both are communicated each other, that is symmetric relations. So friends, Pji m for some and Pij m n for some n, where m does not equals to n. So C1 equals to, you will see that 0 to 1 and 1 to 0, 0 to 2, 0 to 1. So it is 0, 1 and 2. We get a communicate relationships, and C2 is equal to 0, 1, 2, and C3 equals to 0, 1, 2, all the are. So friends, we get it is irreducible. I hope I can clear the definition of irreducible. Now we will solve Markov chain space. Another problem. Then we can see it is the example of reducible. Now you see that P is equal to 1, 3, 1, 3, 1 by 2, 0, 0, 1, 0, 1, and this way, this is the 1, this is 1 by 3, 1 to 1, 1 by 3, 1 to 2, this is 1 by 2, 1 by 3, 1 by 2, and 3 is, we see this is 1, 3 to 0, 3 to 1, this is the 1, 1, 2, 3, 1 2 3. So 3 to 1, we see there is a path that is 1 by 3. Friends, I have already taught how to draw directed graph. So you see, this is my directed graph. Now Ci. Now we see C1, commutative class of C1 equals to 1 comma 2, because we can go 1 to 3 but can't return from 3. No path that we can go, there is no path where we can go from 1 to 3. That's why C1 equal to only 1 comma 2 and C2 equals to 1 comma 2 and C3 is only 3. So friends, this problem is reducible. By the definitions of the irreducibility and reducibility, we will see what is the irreducibility. We see that in case of commutative class does not equals to S. Absorbing state. If closed set contain only one state J, then J is said to be absorbing state, that is J is absorbing if and only if Pjj equals to 1 and Pjk equals to 0. K does not equals to J. Absorbing Markov chain. A Markov chain is said to be absorbing if it contains at least one absorbing state. So friends, for example, you see in here P331. This is the absorbing Markov chain. Now we will go periodicity. Periodicity state I. Now we will discuss what is periodicity, periodic and aperiodic. State J returning state PIIN greater than equals to 0. For some n greater than equals to 1. Period di lambda I of state I, di equals to GCD m such that PIIN for all m. A aperiodic di equals to 1 and periodic dx less than greater than 1. So friends, give an example xn such that n greater than equals to 1 is Markov chain state space 1 2 3. Now we have to find out it is periodic or aperiodic. Now let us draw the directed graph. This is the 1 3 1 2 3. So friends, 0 1 1, no, this is, I can write this way, 0 1 and 2 and 0 1 and 2, 0 0, no, 0 1 0, sorry, not 0 1 1 2 3 is my state space. So I have to write this way, 1 2 3 1 2 3, 1 1, no, 1 2 half and 2 1 is half, 1 2 3 and 3 1 is equal to half. Now 3 to 2, 3 2 to 3 half and 3 to 2 half. So this is half and this is half. So friends, now we will find out P11 2 is equal to half into half plus half into half equals to 1 by 2 greater than 0 and D11 equals to GCD of M such that P11 M GCD equals to 2, 3 equals to 1. So similarly P11 3 equals to half plus half plus half into half into half into half plus half into half equals to 1 by 4 greater than 0. So P113 is also greater than 0, and we will check that GCD of 2, 3 is equal to 1. So it is aperiodic. It is aperiodic if you will check that D2 equals to 1, D3 equals to 1. So now we will discuss stationary distribution. Stationary distribution. Definition. Stationary distribution definition. Xn such that n greater than equals to 1 and p equals to pii. Vii is called stationary and invariant for given chain such if vk is equal to summation j into vj pjk such that vj greater than equals to 0, p equals to p11, p12, p1m, p21, p22, p2m, pn1, pn2, pnm, and v1 is equal to v1, p11, p22. This is the total formula multiplications. So example xn such that n greater than equals to 1 is Markov chain state space 1, 2, 3. So friends, how can we will solve vi greater than equals to 0 and summation vj equals to 1, and now we will multiply v1 2 into v3 with this number half 0 half 0. So after multiplying we get half v2 multiply should be this way, half v2 plus half v3 half v1 plus half v1 plus half v2. Now v1 equals to half v2 plus half v3, we get 2v1 equals to v2 plus v3. Similarly v2 equals to 2v2 equals to is equal to v1 plus v3 plus 2v3 equals to v2 plus v1, and now we know that v1 plus v2 plus v3 equals to 1. So putting the value, so we get v1 equals to 1 by 3 and v2 equals to 1 by 3 and v3 equals to 1 by 3. Another way, friends, you will see, you know that it is double statistics. I will discuss when it is double statistics case after few times later. Now aperiodic, then we have to find out limit n tends to infinity, pn p11 this, and this is standard sd is equal to, means stationary distribution is equal to n tends to infinity p11 n, this value I have to find out. Example xn is Markov state space, so s is equal to 1, 2, 3. So friends, let's start. Let me draw a directed graph. So this is the directed graph. You can write this way, half 0, this is 1, 2, 3, and write 1, 2, 3. So 0 half 1 by 3 1 by 3 1 by 3. Now we draw the directed graph. This is 1, this is 2, and this is 3. 1, 2, 1 is equal to half and 1 to 2 is equal to half, and 2 to 1 equals to half, and 3 to equals to half. This part 2, there is a value, no, we can't get any value from this. Okay, 2 to 3 to 1 is equal to 1 by 3, and 3 to 3 is equal to 1 by 3. So this is my directed graph. And now you see that Ci is equal to S, irreducible, and P11 is equal to half, P22 is equal to 1 by 2, P33 is equal to 1 by 3, and V1 comma V3 and and V1 plus V2 plus V3 equals to 1, and we get V1 equals to half of V1 plus 1/3 V2, V2 1 by 2 V1 plus 1 by 2 V2 plus 1/3, and V3 is equal to half V1. So answer is 2 by 9, 4 by 9 and 1 by 3 after calculating V1, V2, V3. So these equations, when anyone can solve, then we get this value 1/3 V2. So I hope I can clear this concept, and now we will solve another problem, stationary distributions. P equals to 1 by 4, 1. State space is 1, 2, 3, 1, 2, 3. So I just draw the directed graph. This is the directed graph, and you see that 1 to 1, this is 1 by 3, and 1 to 2, this is 1 by 4, and 2 to 1, this is 1 by 2, and 3 to 1, this is 1, and 3 to 1, this is 1 by 3, this way 1 to 3, and 2 to 3, there is no path. 2 to 2, this is the half. So friends, in this case we see that Ci does not equals to S. Ci does not equals to S, and our matrices, our equation, we just multiply V1, V2, V3 with this matrix 1 by 3, that is V1, V2, V3. So multiplying with this, so we get V1 equals to 1/3 V1 plus 1 by 2 V2, and V2 is equal to 1 by 4 V1 plus 1 by 2 V2 plus V3 equals to 1/3 V1. In this way we get V1 equals to 0, and we get the value of this 0, 0, 1, V1, V2, V3, and V1, V2, V3 is equal to this. So limit n tends to infinity equals to 0, 0, 1, 0, 0. This is the limit n tends to infinity p to the power n. Now we will go to the another example. This is the example. So how can we will solve this example? Stationary distribution. I have to find out stationary distribution. So friends, you see, we can write this way: 1 by 2, 0, 1 by 2, 0, 1 by 4, 1 by 4, 1 by 1 by 3, 0, 1 by 3, 1 by 3, and 1 by 2, 0, 1 by 2, and this is 0. So I can write this way: 1, 2, 3, 4, 1, 2, 3, 4. This is my total. Now I draw directed graph. This is my 1, 2, 3, 4, and this is the diagram. 1 to 1, this is half. 1 to 2, this is 1 by 3, and 2 to 1, sorry, this is 3. I can write this is 3, this is 2, and 2 to 1 to 3, this is half, and 3 to 3, this is 1 by 3, and 3 to 4, this is 1 by 3, and 4 to 3, this is 1 by 2, and 2 to 2 is equal to 1 by 4, and 2 to 4, this is 1 by 4, and 1 to 2, this is 1 by 4. This is my total structure, total directed. I draw directed graph because 4 to 3, 4 to 2, 4 to 2, you will not get any. 4 to 2, you will not get any path. Okay, you will not get any path from 4 to 2, and 2 to 4, you get only one path, that is 1 by 4. I hope I can clear this total concept. Now our C is equal to 1, 3, 4, closed plus communicating, closed plus communicating. So friends, reducible element is reducible. This is reducible, this is not irreducible. So reducible, this is the V1, 0, V3, and V4 you get, and after that we can get this problem this way, that we just change 1, 3, 4, 2, because 2 is not our element. So V1, V3, V4. So this is the V1. So my setup combination will be 1, 3, 4, 2, and 1, 3, 4, 2. This way I can write. So in case of 1, whatever we get, 1 by 2, 1, 1 is equal to 1 by 2, and look at this matrix. 1, 1 is equal to 1 by 2, 1, 3 is equal to 1 by 2. So I have to put in here 1 3 equals to 1 by 2. And now look, 1 4 is equal to 0. So it is 0. And 1 2 is equal to 0. This is 1 2. So I am putting in here 0. And 3 1 is equal to 1 by 3. So I get it is 1 by 3. And 3 is equal to 1 by 3. So this way you get, friends, very simple. So 1 by 3, 0. And 4 1 is equal to 1 by 2, 1 by 2. 4 1, you can see the directed graph. 4 1 is equal to 1 by 2. This way 4 1 equals to 1 by 2. And 4 3 is equal to half. And 4 4 is 0. 4 2, there is no between the 4 and 2. So 4 2 is equal to 0. And 2 4 is equal to 1 by 4. And 2 2 is equal to 1 by 4. And 2 1 is equal to 1 by 4. 2 1 is equal to 1 by 4. And 2 4 is equal to 1 by 4. This is my diagram. So friends, you can see I can draw this way. I get a diagram this way. This diagram is this form: x 0 y z. We get this form. Okay, I hope I can clear this concept. Now I will tell some result of the Markov chain. S equals to 1 2 up to n, and alpha n such that n greater than equals to 1. Pij equals to n cross n when it is double statistics. The case is this: when it is double statistics, then SD means stationary distribution equals to 1 by n, 1 by n, 1 by n up to this is the result. Friends, you will see the example. This is the double statistics, friends. Why it is double statistics? Because you at first add in here, this is 1, add this row column, this is double statistics, and you see the stationary distribution SD equals to 1 by 3, 1 by 3, 1 by 3. Double statistics problem. Now limit this should be irreducible. So friends, if the questions will ask this way, that P equals to 0 1 by 2 1 by 2 1 by 2 0 1 by 2 1 by 2 1 by 2 0, then you get that after adding you get 1, it is 1, this is 1, this is 1, and in here you get 1 1 adding and 1. So it is double statistics. So you can get the stationary distribution 1 by 3 because it is 3 cross 3 matrix. Now if they ask the limit n tends to infinity p to the power n, so how you will get this value? This value is very simple. Limit ij equals to 1 by 3, because limit n tends to, so friends, limit n tends to infinity p n 1 1 equals to 1 by 3, and limit n tends to infinity p 1 2 3 equals to 1 by 3, limit n tends to infinity p 2 2 3 is equal to 1 by 3, and limit n tends to infinity into p 2 1 3 equals to 1 by 3. So friends, that important result irreducible plus aperiodic, reducible plus aperiodic, then stationary distribution is unique. Result, important result, that if ii equals to 1, then vi equals to limit tends to infinity piin equals to 1 by mu ij greater than 0. If xn such that n greater than equals to 1 and p equals to 1 minus a b 1 minus b, then limit n tends to infinity p per n equals to 1 by a plus b ba. Example, for example, if the question is 0.7, 0.3 and 0.4 and 0.6, this type of questions, so limit n tends to infinity equals to 0.4, 0.3, 0.4, 0.3 divided by 0.7. P equals to 1 minus p 1 minus p, and limit n tends to infinity p to the power n equals to 1 by 2, 1 by 2, 1 by 2, 1 by 2. So SD equals to 1 by 2, 1 by 2, and limit n tends to infinity pn 1 1 equals to half. Limit n tends to infinity p 1 2 comma n equals to divided by half. Limit n tends to infinity p 2 1 n equals to half. Limit n tends to infinity p 2 2 n equals to half. I hope I can clear this total Markov chain. For watching.